fibre directly between the point where you want the bandwidth and where your hub point is. I'm suggesting here we're using point-to-point gigabit Ethernet, but of course with the fibre, once you've got it in there, then we're ready for 10 gig or any other service parameters there. We've got the usual acronym SOUP. I've done a fibre to the home, then B, we can choose a business, building, doesn't really matter. And to the T is the tower, or small cell, or street furniture. I don't think I've seen FTT SF. I discovered one last week, which was FTTB for boat. There's a company in London now deploying services within a marina, so they've now got fibre to the boat introduced into the lexicon of acronyms. So, point-to-point fibre needs to get back to somewhere. Drawn as a central office, could be a piece of street furniture, could indeed, for Vodafone, also be a macro site. So naturally aggregating back fibre strands via whoever we can get and bring them into a macro site helps with comp and the coordination side of things, but it also means that that point there in the macro site is also where we want to have a reliable, robust service, tends to be where we also then looking at ring resilience to actually connect back together into the network. As we move further up the page, we're sort of looking at different deployment approaches, taking the fibre and splitting it out for GPON. We're now into the type of equipment that's used. Does the ONT support synchronous Ethernet, for instance, if we're looking at it for mobile services? What can we do in terms of 1588 as a stopgap, waiting for the right ONTs to be deployed by whoever we're buying the managed service from? We're also seeing the GFAST, so the reuse of copper into a particular building. Well, it's not much applicable for the outside plant, though the cost of installing copper pair into what they call non-served premises to actually deliver service to a bus shelter, for instance, is going to be a lot lower than actually connecting on fibre. And then we get the various other options as we go with VDSL, where the copper intercepts will be picked up at the cabinet, or indeed older-fashioned technology for the ADSL2 services fed from the central office. So that's one set of options that we consider. I talked about the different speeds. It's really what do we actually want to get at the end user. For everything that we're talking about here for small cells, we talk about the bandwidth and the location. If we look at one individual small cell, then perhaps we're into the area where this new GFAST technology, 5 to the DP, is supported. But as you've seen and heard already, the ability to use local radio hops to aggregate that traffic, bring it back to the point. Most of what I deal with is really talking about we need a pure fibre feed to a particular location, because the traffic's already has some form of concentration or aggregation as it comes through to us. Anybody who spots, oh, I did actually put it on there, acknowledgement. This was the quickest way I could find of actually putting in there a slide about NGPON. Talk about GPON, gigabit shared across a user base. I could have done there are other well-known vendors who were in the room whose slide I could have picked up and done it. But the technology in NGPON is already standards-based to be able to mix and merge different traffic types. The advantage for the NGPON is a central box set at the head end where the traffic types can be brought through. NGPON's not there yet, so it's what do we do in the meantime? What do we do with the right cost point until the technology's matured? So GPON, we're already deploying networks that are NGPON ready, so we'll see the slide in a moment, preparing the outdoor network and the passive network to have the right filters in the field for that. But this nirvana of a single box where you can plug everything into, it's going to be quite a hulking box when considering that the actual technology that we can deal with can run 40 or 80 gig, because it can run 10 gig on a wavelength. There's 4 or 8 wavelengths available in there. We're not quite sure how the kit's going to turn up, whether it be build a wavelength at a time, so buy as you grow in terms of that sort of capacity, or indeed where it's going to be. If we're looking at network sharing and we're delivering traffic on behalf of several mobile operators, does each one of those want their own device out in the field to be able to run their own 10 gig feed however they want to? Or do we have a look at other options where we've got to put an Ethernet switch or something similar to actually deliver the traffic there. The important thing is coexistence. So from our point of view, we have this WDM thing that allows us to merge in GPON wavelengths with the future wavelengths as they become available, hitless operation to actually introduce and add that onto network deployments. We talked about CIPRI just before. Luckily, again, I managed to find a reasonably nice slide until I projected it and realised I probably won't be able to read a word of it. The slides will have this pack in there, but I nicked it from the Optical Communications Conference pack that very nicely sets out a lot of the options that are there. CIPRI on fibre, I think it's South Korea Telecom introduced the concept, but fibre rich, we've got a CIPRI interface on a dedicated pair of fibre, on a dedicated fibre. We're not usually in that luxury, so we virtualise it. We run the CIPRI interfaces on different wavelengths, combine them together, share one fibre pair, and create virtual fibre. From the other approach, you can actually put in an active box and do a muxponder approach there, which also allows you to easily bring in other traffic types, whether it be a sync service, and therefore you've got the ability to take a fibre that's currently not running wavelengths, but overlay it and put in services on the top to pick up and carry the CIPRI as an upgrade approach. There's a halfway house between the active and the passive. Sorry to my ADFA colleagues, but I'll nick this one from Transmode. The semi-passive one gets over one key problem with the pure wavelength approach, which is actually management, diagnostics. Each one of these things is running on its own particular wavelength. How do you know what's actually going on the fibre? How do you get that back? The CIPRI management standards aren't particularly easy to intercept and find out what's going on in your link. So Transmode decided that actually what they'll do is they'll just do a quick loop back and put it onto control unit. It's an Ethernet demarcation unit, and it's just doing your link test all the time. It's a dedicated wavelength, and you get that manageability back in. I mentioned about fibre, but we have within Vodafone also done tests with FTTC, so looking at what we can get out of the copper. It's only a stopgap because obviously with the speed of 80 megs or even with vectoring 100 megs and GFast coming along, there's always going to be the limit of whereabouts do you actually hit the capacity of that particular copper. One of the things we've got is that the equipment that we use obviously delivers copper-based services, great for the Wi-Fi users or the broadband services in a domestic premises or a small and medium enterprise. But the equipment can also take a point-to-point optical card, so active Ethernet 1 gig services can also be provided on there. And that's the sort of stuff that we're looking at of whatever we've got in street furniture, street cabinets delivering our bulk of consumer and SME type services. We've also got the ability to deliver a number of point-to-point active Ethernet services off effectively the same infrastructure that's going through. GPON, similar thing, but obviously on ONTs and stepping into that bonus of GPON ports. What's the split ratio? Where do you think your songs are going to be? Are they aggregated or not? You can choose how to do your split ratio. Now, there's some implications on network design. From my point of view, each OPCO's got their own particular layout. We talked, there was a session just before the main hall about rural communities and the rural infill that EE were doing with putting out their 4G hops to actually get into a rural area. From the fibre point of view, we've got exactly the same thing. We're not going to go dig 500 kilometres of new network around the place. So what can we do? What's the sort of variables? And the key thing from our point of view is to start with understanding whereabouts the blocks of users are, what do they actually have available to them, and to in terms of traffic and demand. And it may be a mix. I talked about macro small cells. It may well be that we've got, in the rural area, we've got the small cells, we've got the rural infill to actually pick up. I've been involved with a project going on over in Ireland, on Vodafone Island, working with the electricity board there to create a rural broadband network, putting fibre up on the overhead power lines which gets us into various towns and rural villages, but also can be used to deliver a fibre strand into maybe a hamlet of 16 to 20 people or houses that are around there. That's sufficient. If we get a strand of fibre there, we can also drop it onto a rural small cell service and actually handle that particular village or valley that's there. I've got a couple more slides to go on there, and then we'll be done.